Today's video will demonstrate how the singleton works. Hello, I'm James Helfrich. The singleton is one of the object creation design patterns. Well, actually, it's kind of an anti-pattern because we want to prevent objects from being created. This video will define the singleton and explain how it works. First, the definition of a singleton. The singleton's job is to ensure that no more than one copy of an object exists. Now let's take a look at how this works. This demonstration is going to be in C++, but of course you can do it in pretty much any language you like. So I'm going to say class singleton. You can call it whatever you want. I'm going to have the public and private components. Now I'm going to have a member variable that it must be static. And static means that all instances of this class must share the same member variable. And I'm going to use the static mechanism to ensure there's only one version of it. Now in C++, when I declare a static, I must then initialize a static globally. And this singleton : p singleton, and that's my fully qualified variable member variable name, is going to be the null pointer. Next, I'm going to have a constructor and it'll be private. And this is a very important detail because the constructor is private. That means that no one else can instantiate an version of this object. If I don't declare a constructor is private, then C++ will generate a public one for me, and then suddenly I lose the whole ability to do so. Now I'm going to have a public method called getInstance. Now, because this method is static, that means that we can access this method even without an object. And it's going to return a pointer to singleton. Now I'm going to say, hey, if p singleton is the null pointer, which means I've not yet instantiated a version, then I will create a new instance of it. Otherwise, then I'll return the instance I have previously created. And this makes sure that no matter how many times I call getInstance, then I'm always going to refer to the same version. Of course, if I never call the singleton getInstance, then it will never be allocated, and then I'm going to have 0 instances. So this mechanism ensures I have between 0 and 1 instance of singleton in the entire execution of the program. Here's an example. I have a video game that must keep an instance of the graphic context, the GC. There must be exactly one instance of the GC object during the game. If there are more, then I'll have multiple windows and things will not work right. Now, of course, what I could do is create an instance of the graphic context object in main and then pass it to virtually every function in the entire program. Oof, that sounds like a lot of work and is probably not the most efficient way to do it. So instead, what I'm going to do is I'm going to create a singleton graphic context. This guy is going to have the graphics pointer as a static. And remember, we make static and UML class diagram with the underscore. And the getInstance will return that instance for me. Therefore, if I try to create more than one version of graphics, well, I can't because my constructor is private, but I'll have to get the instance through getInstance, and I'll always return the same one. This begs the question, when do you use a singleton? Well, there's a couple scenarios. One, I want to use a singleton for logging. 2, I want to use a singleton for external interfaces. And 3, I want to use a singleton to remove a global variable. Let's talk about the logging first. Now, there should be only one logging object. Obviously, if I have more than one logging object, then I'm going to have 2 objects trying to write to the same log, and that might be a concurrency problem, and it's just a nightmare. So I want to make sure I have one and only one. And second, I don't want to pass my logging variable to every function in the entire program. So therefore, what I'm going to have to do is make this a singleton. And then in a getInstance, we'll refer to the single instance that takes care of the logging. And this will ensure I don't have any redundancy. The second, I want to use a singleton for external interfaces. And this is very similar to what I did with my graphic context. Now note that cout is currently a global variable, even though global variables are evil. What I could get around this by making a getInstance for cout, and therefore I can make sure there's only one copy, so I'm not going to have 2 different objects competing for who's going to write to the screen, but then I can also avoid to have that global variable. The final is when I have a global variable, usually the first step is to make it a singleton. Global variables are known to be evil. We've known this for almost 50 years now. So whenever you see a global variable in the code, almost always there's a better way to take care of it. And usually the first step is to make it a singleton. It might turn out there's even a better solution yet. Like you can make it a local variable to a class, or you could pass it to the handful of functions that care, or whatever else it is. But always, 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 the first step is to turn it into a singleton. This was example 39.6 and the singleton section of the object creation chapter of the software design textbook.